Welcome to this video on the one-way ANOVA using JAMOVI. So we shall be looking at an existing data set and a case study. So suppose we have a research question, which is there a difference or is there a significant difference in the academic performance of students across different modes of teaching delivery? Face-to-face, blended, fully online. So what we want to basically test is whether students who have followed the program using a certain mode of delivery, whether fully online, blended mode, or face-to-face, have different academic performance. So can we observe, is there a significant difference between the performance of students based on whether they have followed the program on a face-to-face, blended, or fully online? Or is there no difference? So that's a research question. So our hypothesis, the null hypothesis would be something like there is no statistically significant difference in the academic performance of students between different modes of teaching delivery. So again, the three modes. So basically we're saying here, under the null hypothesis, that the three mean values are equal. Our claim, referred to as the alternate hypothesis, is there is a statistically significant difference in academic performance of students between at least one mode of teaching. Because we're comparing three different groups, and here what we're saying is we expect to find a difference between at least one and the other. So at least one mean is significantly different. So it's a sample based on 108 students, all right? And that's the data we're going to use, and we'll perform the one-way ANOVA using JAMOVI. So let's now move to JAMOVI and let's perform the one-way ANOVA. So to perform the one-way ANOVA, we go on ANOVA and one-way ANOVA. All right. So we click on one-way ANOVA, and then so we look for our dependent variable, which in this case is academic performance, and then our grouping variable, which is the different groups of students based on the teaching mode. So that's the variable in our data set, type of lecture delivery, and we select that as our grouping variable. So you'll see that instantly JAMOVI already gives us the ANOVA, but we'll need to go through a number of additional options here. So additional statistics, we want to have a descriptive table, and we have two assumptions which need to be met when we perform the one-way ANOVA, and they are the homogeneity test and the normality test. The normality test, of course, being common for all parametric tests, and we also have here for the one-way ANOVA the homogeneity test, which is homogeneity of variance test, equality of variances test, in other words. So we'll select those two options. And what we'll also do, we are going to select a post hoc test. Now, the post hoc test will be relevant only if we actually find that there is an overall statistically significant result when performing the one-way ANOVA. And one can say that it's the case here. We have a statistically significant result. Overall, we are p less than 0.05. And therefore, we'll use a post hoc test. But before we proceed, because we need to make a choice, you will see here, whether it's with regards to the main test, the one-way ANOVA, or the post hoc test, we need to make a choice. So here, for example, we have a choice between what's known as the Welch's ANOVA and the Fisher's test. So if we have the assumption of equality of variances which is met, we go for the Fisher's one-way ANOVA, and we say here, and that's why it says assume equal. Actually, it's regarding the homogeneity of variance test. So we say that the assumption has been met, equality of variances, and therefore we choose this one. If it's not the case, then we go for the don't assume equal, the well-choose test, in other words. And it also has an implication for a post-hoc test. So in case of unequal variances, we go for the Games-Orwell test. In case of equal variances, then we go for a Tukey test. Good. So that's a very important assumption here that needs to be tested. So let's look at both assumptions actually. So let's first look at the homogeneity of variances test, which is provided here by the Levene's test. So what we want to actually get here is a p-value which is greater than 0.05. So having a p-value here greater than 0.05 indicates that the assumption is met. Because the null hypothesis here, when we test the assumption, is that variances are equal. There are no differences between the different variances. And that's what we want. We do not want to reject H naught, therefore we want p-value to be greater than 0.05 in the case of the assumptions. And that's the case here, and we can say therefore that the assumption of homogeneity of variance has been met. So we'll select the Fisher's test. We can deselect the other one, the Welch's test. And in terms of a post-hoc test, we'll ask for a Tukey test, where we assume equal variances, right? This is again because we have this assumption which is met, equality of variances. When it comes to normality, we get the Shapiro-Wilk test, and the same here. If it is greater than 0.05, then we can say that the assumption of normality has been met, and that's again the case here. So that's good. But what we also want to check always is the skewness and kurtosis values, because it could happen that the Shapiro-Wilk test gives us a statistically significant result, and we reject the assumption. We reject the assumption that the distribution is roughly normally distributed. And that could be just because we have a large sample and it's overly sensitive, because we just want the distribution again to be roughly normally distributed. So let's look at the skewness and kurtosis, so ACAD performance. And we could also split by a group so that we get it for each group. And now we also need to select skewness and kurtosis, so that's what we'll select. And what do we find? The skewness and kurtosis values. So we see skewness value 0.653, minus 0.06, 0.196. Kurtosis values minus 0.492, minus 0.09, minus 0.86. And all of those are certainly within the range of minus 2 and plus 2, which indicates that the distribution of sample data is roughly normally distributed. And that's something that we want to see as well, because we are using the mean as an estimate here, and we want the mean to be as unbiased as possible and to be a good measure of central tendency, as we say. And if we had severe departure from normality, then it would have been better to actually go for the median, right? In our case here, we're good. The distribution, the sample distribution is roughly normally distributed, so the estimated mean values are relatively unbiased, and that's good. Okay, so let's go back to the ANOVA test. And we're also happy regarding to the population distribution. With regards to that, again, we can be a little bit lenient when we have large sample sizes, because when we have large sample sizes, actually the sampling distribution becomes roughly normally distributed, and that's what we want, in fact, to be able to make inferences using parametric tests. Okay, so far so good. So the assumptions are met, and therefore we choose those options, and therefore those are the results now that we want to interpret. So we have a descriptive table, we have the one-way ANOVA table, those are the assumptions, and then we have here the post hoc tests. So now let's proceed and let's interpret the results. So I'll show you how we would be interpreting the results here, and here you can see the results which have been included. And let's proceed now with the interpretation. And let me find a way to just show both on screen. And I hope that's readable. Good. So first of all, we write a statement about the descriptive statistics. So the descriptive statistics for academic performance of students, that's what we're looking at here, across the 3 teaching modes indicate that students in the fully online mode have the lowest mean score, with a mean of 41.2, standard deviation of 21.5. And this is something you can find here in the descriptives table, 41.2, 21.5. And the face-to-face mode obtained the highest mean score actually, right? And we can see here 55 mean value. But of course, those are descriptive statistics which rely on the sample data. And now we want to see whether whatever difference we observe here is or actually are statistically significant. So we do a one-way ANOVA. That's what we use here. But again, prior to interpreting the results of a one-way ANOVA, we want to report on the assumptions that have been tested. So prior to conducting the one-way ANOVA, the assumption of normality and homogeneity are tested. So first, regarding normality, as we could see, all the values, skewness and kurtosis values, we could see fall within the range of -2 and +2. So we're good. And we write modulus 2 here, indicating between the range of -2 and +2. Regarding the assumption of equality of variances, also referred to as homogeneity of variances, again, we see that this has been met. We have a p-value greater than 0.05, indicating that variances can be considered to be roughly equal. So we find with regards to both assumptions. Now, we therefore proceed with Fisher's test, one-way ANOVA, Fisher's test, and we are going to interpret first the main result, the F test, which looks at the overall differences between means. And what we can see is that we have a p-value here less than 0.05. So the one-way ANOVA shows a statistically significant effect. So we report the F statistic with the corresponding degrees of freedom and the p-value, which is less than 0.05. Thus, we can actually say that the null hypothesis of no differences between the means is rejected, suggesting that at least one teaching mode differed significantly from the others in terms of academic performance. Now, when we look at the main result of a one-way ANOVA, we cannot actually identify which of the mean scores are different, because we're looking at 3 different means. So it could be between face-to-face and online, in our case here. It could be between fully online and blended face-to-face. We don't know, but we know overall the difference is statistically significant. And what we also want to do is to look at an overall effect size, and for that we look at the eta square value, right? So moreover, the effect size indicates a moderate effect, eta square, which is 0.02 here, indicating that the observed overall difference is not only statistically significant, but also practically meaningful, right? In fact, eta square value greater than 0.06 indicate a moderate effect, right? So that's what we find here. And we then proceed with a post hoc test. Now, to evaluate the specific differences between the 3 means, a Tukey post hoc test is carried out. The results indicate that students in the online mode have significantly lower academic performance compared to both face-to-face and blended modes, where p is less than 0.05. However, there is no statistically significant difference between the blended and face-to-face modes, p greater than 0.05. So this is something you can see here in the post hoc Tukey test. Right, here it is. Maybe you can see it better in the table here, right? So what we can find here, when we compare fully online with blended, right? So the p-value is 0.014, so statistically significant difference. And fully online with face-to-face, again, statistically significant, 0.024. But when we compare blended with face-to-face, then we get a p-value which is greater than 0.05 for sure here, and we can say that the mean difference is not statistically significant. So therefore, the statistical difference between means, it's specifically between fully online and the 2 other ones. Okay. So that's what we're saying here. And we also can actually look at the effect size for the post-hoc test. And we found that coens D is equal to 0.72 and 0.73 respectively, which indicate relatively large effects. Right. This suggests that the observed differences are also significant in practice. And that's what we can conclude here in that case. And overall, actually, what we can say is that students having followed a fully online mode have lower academic performance compared to those who followed the course on a blended or face-to-face mode, right? So fully online mode, much lower compared to the other two groups. But between blended and face-to-face, we have no difference, no significant difference. By the way, when we actually perform the one-way ANOVA on JAMOVI, actually we did not obtain those two values straight away. So let me just go back to JAMOVI and show you how we'll obtain that. In fact, when you actually run the test using the option ANOVA, one-way ANOVA, you do not have the option for the effect sizes. It's not there. So what you should instead do is go on ANOVA and click instead on the option ANOVA. Right. So we need to do the same thing again. So academic performance here, type in the fixed factor here. And now we have the option of eta square, which is the effect size for a one-way ANOVA. And we also can go on post-hoc test and we'll select Turkey. So we make sure that this is selected here. So we get the same results, but we also have the option of coens D, and we can also find if you want confidence interval of a coens D if you want. But yeah, so now we get those values which I reported. So the coens D here. Okay, so always important to include effect sizes, because that's what indicates the practical significance of the results. So it's not enough to get a result which is statistically significant. That can often be misleading. You also want to ensure that the results are meaningful in practice. Right? In medical science, we refer to that as clinical significance. So differences, effects, which actually does matter. Okay, so that's how you would obtain the effect sizes. You need to go on ANOVA and use the option ANOVA instead. Well, you could actually, at the first instance itself, if you want the effect size, just go for ANOVA instead of one-way. Pardon. I'm sorry. So for some reason, JAMOVI doesn't provide us with the effect sizes when you go on the one-way ANOVA option. Probably that's something they will add afterwards. Okay, so that's it for the one-way ANOVA. Well done to have made it to the end of a video, and I'll see you in another video. So cheers and bye bye.